So our next speaker is Liz. She's a software engineer focused on JavaScript, and she's the head of developer relation at NodeSource. She organized many well-known community events, such as JSConf Colombia, which I would really love to visit, and Empire.js, Node.js Interactive. She loves sharing knowledge, and I can definitely confirm this, as I always enjoy reading her blog post. So, hello, Liz. Welcome. How are you?
Hi. Thank you for having me here.
How are you?
Very, very good. Yeah.
Oh,
And
good.
you? How are you?
Quite good. A little bit tired, but very happy
Yeah,
about the day. So,
a long day.
what's time is it in your time zone at the moment?
It's 10:15 in the morning.
10,
Yes.
15. Okay, so about 7 hours in the
Yes,
past.
7 hours.
Okay, great.
I missed the
So,
talks because I missed a lot of talks because yeah, it was very early for me, like 4 in the morning. But yeah, I saw the last couple of, they were really good.
yeah, they were absolutely. Okay, so thank you for being here again, and see you in a bit, just after your talk.
Yeah.
Hello! Today I will be talking about examining observability in Node.js. My name is Liz Parody. I am from the beautiful country of Colombia and I'm head of developers relations at NodeSource. So let's begin. This is the agenda for today. First, we're going to talk about what is observability, why observability is important, how can we use Node.js internals for observability, and we're going to see some tools, and also some external tools, benchmarks, and at the end, some conclusions. So, what is observability? Observability is a term from control theory. According to Wikipedia, observability is a measure of how well internal states of a system can be inferred by the knowledge of its external outputs. In other words, we can see the results of the outputs and we can know what's happening on the inside. Let's take, for example, bananas and avocados. In Colombia, we have so many bananas and avocados. It's amazing. And just by looking at the outside or even touching them, we can know how it's on the inside, if they're ripe or if they're not ready for consumption yet. In software products and services, observability means you can answer any questions about what's happening on the inside of a system by observing or asking questions from the outside without needing to ship new code to answer questions. And that's very important. We shouldn't need to write new code to observe what's happening in our system or our code. Because system complexity is outpassing the ability to predict what's going to break. There are super useful tools that come to the rescue. Talking about system complexity, software is becoming exponentially more complex. In infrastructure, we're seeing things such as microservices, polyglot, persistent, containers, Kubernetes, Docker, and others that decompose monoliths into microservices. Great for products, hard on humans. The number of products and tools are also multiplying. There are countless of platforms and tools for empowering people to have better observability and control over the code. Great for users, hard to choose the best one. To successfully deliver and run a product or services under these escalating conditions, you need observability. Now that you know what observability is, you will be wondering why it's important and why you should care. With environments as complex as we see today in modern applications, simply monitoring for problems is not enough to recognize, find, and fix the number of issues that arise. Sometimes the new issues are unknown unknowns, which are problems that you don't know, and even worse, problems that you don't know how to find. So without tools to observe the environment, it's almost impossible to solve these issues. This is why observability is important. It gives you the instrumentation you need to understand what's happening in your software and fix it. A good observability tool helps you find what and where the problem is. It doesn't add overhead to your app because we don't want our app to slow down. Quite the opposite. Has enhanced security. We don't want any data breach. Has flexible integration and doesn't need to modify your code. It's important to differentiate between observability and monitoring. Observing is exposing the internal state to be viewed externally, and monitoring is collecting and displaying the information that has been exposed, and usually involves writing automation tools around that. Now, let's imagine your productivity and confidence developing web apps without Chrome DevTools. Many do that exactly with Node. I think every web developer on the planet has used Chrome dev tools at some point, but not a lot of Node.js developers have used similar tools to observe their Node.js applications. If you want to solve the most complex Node.js problems such as memory leaks or performance issues, or even just follow the best practices to keep your code healthy, it's necessary to have an observability tool. The next step will be choosing an observability tool or a tool that adapts the best for our needs. First, we're going to see which observability tool can we use in Node.js internals, and then we're going to check some of the external tools for Node.js observability. So in Node.js internal, first we're going to find performance hooks. This is particularly helpful for checking on performance. It's an object that can be used to collect performance metrics from the current Node.js instance. Performance monitoring is not something you should start considering once you start seeing performance issues. Instead, it should be part of your development process in order to detect possible problems before they are visible in production. Because of the asynchronous nature of Node.js, code profiling with regular tools can be challenging, especially because part of the time spent could be outside of your code and inside of the event loop itself. This is why it's important to use either internal Node.js tools like Performance Hook or external tools as we're going to discuss later. Let's measure, for example, the performance of the top search engine, Google, Yahoo, Bing, and DuckDuckGo, using performance hooks. So here we're using performance and performance observer for first hook. Then we're going to check the 4 search engine, Google, Yahoo, Bing, and DuckDuckGo, and then we're going to loop through those 4 URLs using performance hook. Here I have the performance observer, and then it will show us the load times of those 4 search engines. Here, if you just do this, we can see that Google is the fastest one, followed by DuckDuckGo, Bing, and finally, according to this script, Yahoo is the slowest one.
Next one is timers. Timers help us control the timing of code execution. You're probably familiar with set timeout, set immediate, and set interval. If we look at the code, we can see set timeout, set interval, and set immediate. And at the end, we can see console log saying, I am a normal statement in the event loop. Guess what comes next? And if we look here, we can see that set immediate would execute immediately. Then at timeout, 3 seconds, and an interval, it will execute every 5 seconds forever. Performance hooks even has observers for measuring the execution time. For example, if we see this code that just says hello world, and we just do this, we can see that this hello world took 13 milliseconds. While informative, there are some trade-offs. It requires instrumentation of the code manually, impacting readability. In case of performance observer, there is a significant overhead cost to the observant. Next one, trace events. The trace events provide a mechanism to centralize tracing information generated by V8, Node.js core, and user space code. Tracing can be enabled with the trace event category command line flag that accepts a list of comma-separated categories names by using the trace events module. By default, Node async hooks, and VA categories are enabled. You can execute trace events enable flag to get the output of several events that happen inside of Node.js. This can include accessing the file system, performance data, async hooks, and others. You can configure which events you want to see by using the flag trace events category, allowing users to create custom trace events and use them, for example, to see how long an operation takes. You can open Chrome Tracing, click the record button, allowing you to visualize tracing like this. If you look at the bottom of the screen, you can see fs.sync.read. This is a read operation of the file system. There are 546 bytes read. It's also possible to see when the tracing started, how long it took, and the CPU duration, which is very useful for seeing what's going on with your code. The next one is heap snapshot. A heap snapshot is a static snapshot of memory usage, detail, and moment in time, and it provides a glimpse into the heap usage of V8, the JavaScript runtime that powers Node.js. By looking at these snapshots, you can begin to understand where and how memory is being used. Heap snapshots are very useful for finding and fixing memory and performance issues in Node.js applications, especially memory leaks. A few years ago, developers had to use the heap.dam module to obtain heap snapshots. Today, they have a built-in heap snapshot signal flag, which is heap snapshot signal, so you can send as many signals as you want, and Node.js will dump the heap snapshot. Chrome DevTools allows you to compare snapshots, and you can identify objects in memory that will help you narrow down where a memory leak might be occurring. This is how a heap snapshot looks like in Chrome DevTools at a very high level. The column on the far left lists the objects on the JavaScript heap. On the right, you can see the objects count column, which represents how many objects are in memory, the shallow size column, which is the amount of memory allocated to store the object itself, not taking into account the reference objects, and the retained size column, which is the shallow size plus the shallow size of the objects that are accessible directly or indirectly, only from this object. In other words, the retained size represents the amount of memory that will be freed by the garbage collector or when the object is collected. The next one is the V8 inspector. This is not an observability tool, but instead it's a development tool that helps you monitor what's happening on your application. A few years ago, Chrome DevTools was integrated directly into V8, expanding its capabilities to include Node.js application. With this integration, it was possible to access step debuggers without having to install the Node Inspector module. There are a few ways to get started. One is using the inspect flag, which will start the inspector. Then you can pass a host and a port that you want to listen to, which will connect later to the inspect flag. If no parameters are passed, it will connect to the 127 port by default. Another way is more useful when doing local development, using the inspect break flag. This flag has the same options for host and port than the inspect flag, but also puts a breakpoint before the user code starts. So you can do any type of setup you prefer without having to try catch points on your code at runtime. Let's do a little demo. If we look at the code here, promise, reject, new error, a very cool error here, and then we go to the terminal and use the inspect break flag, we can see a message printed on the console. Debugger is listening to on WS, followed by a WebSocket URL. WebSocket makes it possible to open a two-way interactive communication session between the user browser and the server. We can also see a message that directs user to the Node.js documentation so we understand what's happening in here.
Then, if we go to the URL chrome inspect, you will see something like this. Once you click on the dedicated DevTools for Node.js link, you can see a pop-up window for debugging your Node.js session, like this. DevTools is now connected to the Node.js, providing you with the access to all Chrome DevTools features you're used to. This allows you to edit pages on the fly and diagnose problems quickly, which ultimately helps you to build better websites faster. Access source maps for transpiled code, live edit, JavaScript hot swap evaluation with V8, console evaluation with EXIS feature object support and custom object formatting, sampling JavaScript profiler with flame graph, heap snapshot inspection, heap allocation timeline, allocation profiling, and asynchronous stack for native promises. However, the V8 inspector should never be used in production because DevTools actions halt the event. This is acceptable in development, but unsuitable for production environments. For production environments, we will see later which one is the best option. Some of the problems with the things that Node.js provides for observability, like timers, performance hooks, and others, is that it tells you that there is a problem, but it doesn't tell you where to find it. Also, sometimes they're not easy to implement. It doesn't give you enough information, or is not presented in an easy way like graphs or external performance metrics that external tools provide. The ability to correctly monitor the process is limited by how much data is exposed. How that data is exposed are the observability tools that we're going to see next. The first one is the blocked library. The blocked npm package is a concise example of using timers for observability. It helps you check if the event loop is blocked. If you're running Node A or higher versions, you can get a stack trace pointing to the blocking function. The block function reports every value over the configured threshold, defaulted to 10 milliseconds. You can then do whatever you want with that value. to do a graph, to log it, alert, etc. While it's useful for understanding the overall health of the event loop, it can have false positives in some scenarios because of the timeout offset. In addition, it can also create a numbing effect, alerting you to the event loop blocks but not signifying or cluing into what is actually causing the blockage. Many times, developer will just ignore as there is no clear action to take. The next one is New Relic. New Relic is an observability platform built to help engineers create better software. From monoliths to serverless, it helps you to instrument everything, then analyze, troubleshoot, and optimize your entire software stack, all in one place. It also provides different solutions, from cloud adoption to digital customer experience in different industries, e-commerce, media, public sector, to name a few. This is how New Relic's insight appear. You can see web transaction times, the application activity, error rate, hosts, and other metrics. The next one is Datadog. Datadog is a monitoring service for cloud-scale applications, providing monitoring of service, databases, tools, services through a SaaS-based data analyst platform. With Datadog, you can check requests, latency distributions, error percentage of time spent, and other metrics of your Node.js applications, as we can see in this very short video. The next one is Instana. Instana is an application performance monitoring APM for microservices. It lets you manage the performance of your application in real time and see every detail about the inner workings and inner dependency of your application services. You can trace event, distribute requests, map all the service dependencies, profile every production process. We can see some of the metrics like calls, error rate, mean latency, top services, processing times, and others. The next one is Dynatrace. Dynatrace produces a software intelligence platform based on artificial intelligence to monitor and optimize applications performance and development, IT infrastructure, and user experience. They focus mainly on these 5 categories: advanced observability, continuous automation, AI assistance, cross-team collaboration, user experience, and business analytics. For Node.js observability, it can tell you the number of processes, the CPU and memory usage, the percentage of connectivity and availability, the traffic, the most time-consuming requests, and other useful Node.js metrics. Next one, we have Google Cloud for Node.js monitoring. Google Cloud Operations, formerly Stackdriver for Node.js, provides monitor, troubleshooting, debugger, error reporting, logging, and others on your Google Cloud environment. But there's a problem with all of these solutions. The way APM works is they become agents, which are intermediaries between your application and the Node.js runtime. The APM is injected to your code, and it encapsulates your application so they can extract the information, and that has a cost, also known as overhead. I have heard that sometimes the APM itself is the one that creates the performance problems. And you can see APM code in overhead in the metrics provided, like CPU profile, stack choices, and others. You can see the APM code and cost. Another problem is that sometimes you have to modify your own code in order to implement the APM, which creates extra work and an extra layer of difficulty that we don't want to deal with. Now, let's see one tool that doesn't have this problem because it's not an APM. It's an enterprise runtime for Node.js, and it doesn't add overhead, and you don't have to modify your code at all. Nsolid. Nsolid is a drop-in alternative for the Node.js runtime, enhanced to deliver low-impact performance insights and greater security for mission-critical Node.js application. It has faster resolution, stronger infrastructure, hardened security, and also zero code instrumentation. That means you don't have to change your code in order to implement it. And also minimal performance overhead. This is important because traditional APM tools sits on top of the Node.js runtime layer. Performance overhead might vary from one application to the next, depending on the architecture and stack used. Some tools sacrifice more detailed stack trace information in an effort to minimize overhead. And none are built specifically with Node.js in mind. Nsolid was built specifically for Node.js. because it's a runtime itself. It's not an agent and is not an intermediary between the application and the Node.js runtime. This is the console overview that provides value insights into clusters of Solid processes running a variety of configurations. You can see the number of processes, vulnerabilities, hosts, and the number of applications. The cluster view is where you can see each process's heap use, the CPU percentage, the garbage collector counts, and others. It's important to clarify that the previous tools I showed, like New Relic, Datadog, they all contain libraries that help expose data, but their main function is as a monitor. For example, I cannot export data using the New Relic API. I consume it via AWS. This is where Solid has an advantage. The traditional metrics that Solid provides can be consumed by any monitoring solutions and without any additional overhead. It's the best of both worlds. Finally, and now that we have seen some tools provided by Node.js internals and some external tools, let's see some benchmarking that compares the most important features of an observability tool. If we're going to check load times, which is the time it takes for a Node.js process to be available to receive and process requests, we can see that vanilla Node.js has the fastest with 30 milliseconds, followed by Solid with 40 milliseconds. Then we can see Instana with 310 milliseconds, which is an increase of 600%. New Relic, Datadog, and finally AppDynamics, which has an increase of 3,600%. As we can see, some of the load times of these external tools can be quite high, except for Solid. Now, the startup times. Node.js takes 30 milliseconds to start, and Solid 35 milliseconds. AppDynamics and Datadog 150 and 250 respectively. Adding baggage. Solid only adds 2 megabytes of memory overhead, while New Relic adds 15 and Datadog 57. And if we're going to measure speed, Datadog and AppDynamics take 2,000 RPS, while Solid is almost 10,000 RPS, which is super fast. Finally, as a conclusion, observability in Node.js is very important for security and performance. It allows you to fix errors faster, and if you're focusing on Node.js specifically, Solid is the best observability tool out there. The other tools are great, but they come with a cost because they add noticeable overhead from wrapping the user's code into their own libraries. Solid avoids these penalties by observing the application at a lower level, allowing Solid to make observations without directly affecting how the program runs. For other types of applications, and depending on your needs, there are other great observability tools out there that adds a lot of value. Thank you so much for watching my talk. And if you have any questions, this is how you can contact me. Bye.
So here we are. Thank you for your talk, Liz. It was very, very interesting. It's so cool to see how many tools we have already available for understanding how our application is behaving. It's really, really impressive. You show so much things that I really want to start playing right now with at least half of them. Oh gosh.
Yeah, and even I didn't show them all. I showed them like the most important and the most popular, but there's like a lot.
Question that comes to my mind says, now I really want to start playing with all of this. So of all the tools you've shown us, what should be the first you will recommend to use? Let's start easy with the one that you have already know without going with external services.
Well, the tool that I would recommend to use, you mean internal or external?
Internal to Node, so something that we already have in our computer via Node or Chrome, basically.
Yes, so performance hook, I think they can be like very interesting performance hooks, yeah, of Node.js. You don't have to install anything, and yeah, it's easy.
Okay, which is, if I do recall correctly, something that has been added quite recently, right? To Node.
Yes, it's quite recently. I think if I'm not wrong, I think it's still experimental, but it gives you like a lot of information. And also the V8, you can also use the V8, like all the things are, because it also has provides a lot of information, but that's only for development, not for production. So yes, I think performance hooks can be interesting.
Okay. So when you think is the right time to start implementing APM in your application?
Well, it will depend of the team and in which stage of development process they are and the complexity of the plans they have too. Because in general, it's always advisable to monitor your application, always, because all of them, all the applications at some point will present some failures or bugs or errors. And it's also important to know what happened in certain periods where there is a big peak of users, if the application is fast or if it breaks. So monitoring in this case will be important. So I would suggest to not start monitoring once you have a problem and once everything is on fire, but start monitoring before, like before, when you see that your application is growing a lot, and yeah, so before
It's
you have
basically
problems.
it's basically like saying that you should fasten your seatbelt before doing
Yeah,
the car crash. Yeah.
exactly.
Okay. Can I get metrics for a post-mortem analysis with an APM or any other tool?
Well, I don't know if all of the npms lets you collect metrics for postmortem analysis. That's only possible when the npm is attached to the runtime, like in solid. And solid allows you to do that, so that's why it's important to choose an observability tool taking those things into account, so you can choose something that adapts the best for your needs. Yeah. So yeah.
Is it also possible to, I guess not in the Node.js itself, but connect the logs that we are getting from the application to the APM traces in our monitoring system?
Yeah, it's possible. Like it's possible to have all the logs and everything depending of the npms. I don't know if, like, I don't know in depth all the npms tools out there, but I know some of that allows you to do that.
Okay, great. Well, I don't think there are other questions from the chat, so thank you a lot. Again, it was very, very cool, and hope to see you next time.
Thank you.
Thank
Thank you
you.
so much for having me and for creating this event. Thank you.
Thank you. Bye.
Bye.